Welcome back to another exciting video. Today, we will be discussing the mind-boggling topic of what would happen if the sun became a dwarf star. So, sit back, relax, and get ready to be amazed as we dive into this thought-provoking subject. Have you ever considered the potential consequences if our sun were to suddenly turn into a dwarf star? Well, today we'll explore this possibility and uncover the fascinating answers. Now, that's a thought, isn't it? It's a question that touches on the very fundamentals of our existence. Today we're going to delve into this fascinating hypothetical scenario, exploring the nature of dwarf stars, comparing them with our sun, and imagining the process of this cosmic transformation. So fasten your mental seatbelts and prepare to journey into the cosmos. Let's dive into the world of stars and unveil some cosmic mysteries. First, we need to understand what a dwarf star is. Picture a celestial body, a star just like any other but with a twist. Dwarf stars are the universe's compact wonders, with their size only reaching up to 20% of our suns. Despite their relatively smaller stature, don't be fooled. These stars are no less fascinating. Dwarf stars come in a variety of flavors, if you will. There are white dwarfs, red dwarfs, and brown dwarfs, each with their own unique attributes. White dwarfs are the remains of stars that have exhausted their nuclear fuel. Red dwarfs, on the other hand, are the most common type of star in the universe, with a lifespan that can stretch into trillions of years. Brown dwarfs, sometimes called failed stars, are interesting creatures that sit right on the boundary between stars and gas giants like Jupiter. So how do these stellar wonders form? In the case of white dwarfs, they are the end product of a star's life cycle, usually one similar in size to our sun. Red and brown dwarfs, however, form just like any other star from a collapsing cloud of dust and gas in space. But here's what's really intriguing. Despite their name, dwarf stars can pack quite a punch. Some white dwarfs, for instance, can end their lives in a supernova explosion, outshining entire galaxies. Now that we have a grasp on what a dwarf star is, we can start comparing it to our sun. Our sun, a magnificent ball of hot plasma, is quite different from a dwarf star. Now let's delve into these differences. Size matters in the cosmos. Our sun, a typical star, stands at a grand diameter of approximately 1 million kilometers. It's so large that over 1 million Earths could fit inside it. Now let's compare this with dwarf stars. These celestial bodies are, as the name suggests, significantly smaller. A white dwarf, for instance, is roughly the size of our Earth. Yes, that's right, a star the size of our planet. Next, let's talk about brightness. Our sun, a beacon of light and energy, is vastly brighter than a typical dwarf star. This is because the sun is currently in its main sequence stage, where it's busy fusing hydrogen into helium, creating a tremendous amount of light and heat. On the other hand, dwarf stars, like white or red dwarfs, have exhausted their primary hydrogen fuel and are thus less bright. Moving on to lifespan, our sun is middle-aged with a life expectancy of about 10 billion years. Dwarf stars, however, are the true long-livers of the universe. A white dwarf can hang around for trillions of years, outliving our sun by a significant margin. This is due to their slower nuclear reactions and efficient use of their fuel. Lastly, let's consider composition. Our sun is primarily made of hydrogen and helium, the two lightest elements. Dwarf stars, on the other hand, consist mainly of heavier elements like carbon and oxygen. This is a result of their long life and the fusion processes they've undergone. Thus, we see that our sun and dwarf stars are worlds apart in many respects. But what if these worlds collide? Stay tuned as we venture into the intriguing possibilities of our sun's transformation into a dwarf star. So what would happen if the sun became a dwarf star? Well, let's start with the temperature. The sun, as we know it, is a warm and friendly giant, bathing us in its comforting heat. But if it were to transform into a dwarf star, its temperature would drop dramatically. Instead of the familiar warmth, we'd be facing an icy cold sun, a chilling thought indeed. Now let's talk about light. The sun is our primary source of light, illuminating our world and making life possible. But a dwarf star? Not so much. It would be significantly dimmer, casting a much fainter light on our planet. Imagine a world bathed in a perpetual twilight, a dimly lit existence that would be a stark contrast to the bright day we're used to. But the changes wouldn't stop there. The sun's transformation would also affect its gravitational pull. Currently, the sun's mass holds our solar system together, keeping all the planets in their orbits. But as a dwarf star, the sun's mass would shrink, and so would its gravitational force. This could send the planets spiraling out of their orbits, causing chaos in our solar system. Now let's consider the impact on Earth. With a drastic drop in temperature and light, life as we know it could cease to exist. The cold and dim light could spell the end for many species, including us humans. Our planet could turn into a frozen wasteland, a far cry from the vibrant world we currently inhabit. And what about the wider solar system? With the planets thrown into chaos, the entire solar system would be destabilized. Who knows what new celestial arrangements might form, or what cosmic events could be triggered? Indeed, if our sun became a dwarf star, it would be a catastrophic event, changing life as we know it. Let's revisit the key points discussed in this video. We started off with understanding what a dwarf star is, a celestial body that's smaller, cooler, and less luminous than our sun. We then compared our sun to dwarf stars, highlighting the stark differences in size, temperature, and brightness. Our journey took us to an intriguing scenario, the transformation of our sun into a dwarf star. We delved into the potential impact of such a transformation, exploring how it would drastically affect our solar system. The reduced heat and light would usher in a new ice age on Earth. Life as we know it would cease to exist, and the orbits of planets would be altered. Yet, despite the grim possibilities, it's important to remember that these are just hypothetical scenarios. In reality, our sun is not expected to become a dwarf star for another 5 billion years or so. The universe is full of wonders and possibilities, some fascinating and some alarming, but isn't that what makes it so intriguing? That's all for today's video. If you find this video very helpful, consider liking and subscribing to the channel to join us on some more hypothetical journeys. Hope you all have a great day.